Hi, everybody. I hope that you enjoyed the keynotes, had a good morning, got some coffee. As Peggy said, my name is Danielle, and I'm the engineering manager of the platform team at Apollo. So my team does product engineering, and the product that we build is called Graph Manager. So one of our main goals at Apollo is to make sure that everybody using GraphQL is successful and productive with that endeavor. Developer experience is something that a lot of people in our company are very passionate about because it's our mission to make software development more accessible by building tools that make traditionally challenging aspects of development easier, more approachable to manage, accessible for more people. When people ask us, what is GraphQL, what do we typically say? GraphQL is a way to communicate between a client and an API. Most of the time, we think of that API as being a GraphQL server, but it really doesn't actually have to be a server. It can be any entity that responds with data in the right shape. The client sends a query, which you see in this picture. The API returns a response with the right shape. That's GraphQL. That's why we're all here today. So my talk today is not a typical GraphQL talk, because we're not going to really be talking much about data fetching. When we talk about the value of GraphQL, we almost always talk about it from a technical perspective. But what I want to show you today is a different way to think about the value of GraphQL that's more focused on the improvements that it brings for you, the developer, not just the improvements that it brings for your application's code in a technical sense. So GraphQL is not about any of these things. It's not about smaller payloads. It's not about fewer client-server round trips. And it's not about preventing overfetching. And yes, these are fantastic technical benefits of GraphQL that lots of people have written great content about. But to me, these are not the most compelling reasons to actually adopt it. Teams typically make the case to adopt GraphQL for the technical merits. But then once they've actually gotten it into production, got it into their workflows, what they say their biggest value was the productivity boost that it brought their developers at all levels of the stack. So the excellent developer experience is really where GraphQL shines. And it's the reason your team will be most happy that they have decided to adopt it, regardless of why they chose to do it up front. Here's a little overview of what's coming for the rest of the talk. We're going to be talking about what good developer experience looks like in a very general sense. We're going to be talking about the developer experience of data fetching. And then we're going to write some code together, and we're going to see what the developer experience of data fetching looks like with GraphQL. So what does good developer experience look like? To talk about this together, I want to start by taking us on a walk down memory lane. I remember having a very serious conversation in 2015 about how we should manage front-end state in applications. The question of the day was really, should we use Flux or Redux? In the moment, Redux was much newer. Flux was kind of the incumbent. And yet in the last 4 years, we've seen Redux really become the pervasive way that people manage front-end state in applications, which we'll look at later in the talk. In 2016, one of the big priorities that I had was helping us modernize our front-end code base from this React.createClass method to using straight class components on React, which feels like eons ago to me, and it's really only a couple of years. In 2017, the hot thing was higher order components. And so we had these GraphQL wrapper functions everywhere in our application. And this was an iteration on the pattern of using React mixins for data fetching, which we had been using prior to this. But it turned out that using static composition like this to wrap your functions, or wrap your components in functions to fetch data, didn't always really give us the flexibility that we wanted in our components to be able to make dynamic rendering decisions based on the state of that data. So in 2018, we had this very big shift to move to query components from higher order components. And this gave us a really nice pattern for rendering data dynamically based on the state of the data that was being fetched. But at the same time, using React components like this to actually represent your queries kind of created a false hierarchy in our DOM, because queries aren't exactly the same thing as divs and layouts. So this led us all to the React hooks pattern of 2019, which has given us a very, very nice way to render components dynamically based on the state of the data being fetched without introducing any of the false hierarchy into our application's DOM structure. And in addition to that, as we heard from Matt in the keynote, as we heard from Bree, the React hooks pattern also pairs extremely well with TypeScript, which makes it very easy to type the data coming back from your API, whereas our previous patterns for this had actually been, they had made typing kind of a challenge. So a lot of folks like to tease the JavaScript community for changing its patterns and best practices so frequently. But the reason we've seen so much evolution in application development, even in just the last 5 years, is because our applications' needs have gotten substantially more complex. So as a result, we've needed to innovate on our language, our frameworks, and our tooling, and our day-to-day workflows, all to make it possible to build more complicated experiences. And when I think about what some of the developer tools are that have substantially changed the way we build applications for the web, the first that comes to mind for me, no doubt, is React. What did we have before React? There are lots of front-end frameworks that you can use to scaffold HTML. You can use handlebars, you can use Angular, you can use Ember. But before a lot of us started using React, a lot of us were just using plain old jQuery. And the first time that I internalized that a React element could mount and unmount itself, and it could hold its own state, and that as a result, I didn't need to manually set my div's inner HTML to an empty string when I wanted to hide it because I clicked a button, it was a really eye-opening experience for me. Or how about prettier? So I personally didn't think that the status quo of formatting my files with tabs and spaces was a problem, because a file is a piece of art. Formatting it is part of writing it. But I can't even begin to state how much time prettier has actually saved me when I'm writing files. It's not just that I don't think about spacing and linting anymore, but I kind of realized through prettier that formatting code isn't something you actually have to really spend time doing, necessarily. And now whenever I have to format my code by hand, or whenever I have to write a document for work by hand, and I don't have a theme and a template already set up, I feel like I'm moving extremely slow. Because at the end of the day, I just realized that formatting is not necessary for that content. Or how about VS Code? So VS Code's support of TypeScript is incredible. And now, as application developers writing code that runs in a web browser, we're all finally reaping the benefits of static typing that other developers in the industry have been laughing at JavaScript developers for not having for a very long time. So all of this is to say great developer experience sparks joy for us. When things are going well in development, it can be very fun and rewarding to be building apps and writing code. And this brings me back to talking about data fetching. What's one of the most challenging aspects of writing apps today on the web? We write a lot of data fetching code. It's very tiresome and draining. Data fetching in React is not really the best experience, because React has taken a very unopinionated stance on how you should fetch your data, which means that there's not a lot of clean and well-known structure and patterns to this problem. So this is a tweet from Adam at Airbnb. He says that of their 2 million lines of JavaScript, only 10 to 15% is actual business logic. The rest is just styles and data fetching. And while that's kind of a crazy statistic to sit back and think about, this is also the boat that most of us are in. So what is the answer to this data fetching messiness? Well, the answer is that you need a front-end data layer, because every front-end application that fetches data from an API, it needs a way to track loading and error states. It needs a way to cache network responses so that you're not needlessly refetching data as your user tabs around your application. It needs a way to persist client state across sessions so that you can provide your users with a come back where you left off from experience. And when applications get big enough to actually need to handle all of these things, the first thing React developers tend to say is, oh, great, OK, let's just throw it all into a Redux store. Because for most of the history of React, Redux has been the best documented way to do this and the advice that we've all gotten. But Redux at its core is just an event emitter. And so it's itself actually a very small amount of code, which means that if you want to use it for this problem, you end up writing a very large amount of code. You end up writing a bunch of middleware. You end up writing a bunch of actions, selectors, reducers. It adds up to a lot of code in the end. So GraphQL is shaping up to be the next huge innovation for front-end developers. What React did for organizing your UI and making it possible for you to build encapsulated, isolated components that manage their own state, GraphQL and Apollo are bringing the same exact organization to your data layer. You should be able to model your data and write your queries, and the rest, the data fetching, the loading, the transitions, the error states, the transport formats, the caching, the pagination, the optimistic UI, this should all be handled for you, because the data in your graph is what's truly unique to your application, your business, and your customers, and the rest, These are all problems that every single application has at scale. So for the next part of the talk, I want to write some code together, and I want to show you what it looks like as a developer to use the modern stack of React, Apollo, and TypeScript, embracing this workflow of having a graph and having proper tooling for that graph. So the concept for our demo is going to be, what does it look like to translate an app that is using REST and Redux into an app that is using GraphQL and Apollo? And I wanted to mimic an app that already existed out there so that we could compare. So I looked at the Redux examples, and there's an app in there called the Real World Example. And that app is built on the GitHub REST API. So we're going to be looking at that app, and then we're going to be rebuilding it on the GitHub GraphQL API. And code demos are very intimidating, so if you see any typos, please shout them out. I will be very grateful. Is this big enough for everybody? Thumbs up in the back? OK, perfect. So this is the Redux real-world example. It's very simple. I have an input box. I can type in my GitHub username. If I hit go, it will load from the API my GitHub picture, my full name, and my list of starred repositories. And while this page looks relatively simple on the right, the code to load this page is actually kind of complicated. So we've got our user page file over here. And for anyone who has been using React for at least a year, this pattern is probably going to look pretty familiar. So we've got this login prop, which is the name that GitHub has given your username when you're interacting with their API. So login is our username. We've got this user prop, which is an object that is the data that we're showing from our user. We've got this load user function, which is a function that gets passed to the page so that the page can call it so that it can load the user once you've typed in your login. And then down here, we've got this map state to props function, which is what's actually reading state from the Redux store and passing in these props to our file. And not only this, but we're not actually doing any data fetching in this user page file. So all of our data fetching is over here in our actions file. So you can see in our actions file, we've got our fetch user function, our fetch repo function. This is where the data is actually getting fetched and where we're triggering different transitions, like I'm loading, I failed, I succeeded. So I won't dwell too much on our Redux app because I want to spend time building our app. But the main message here is that this is a lot of repeated boilerplate code. So what does it look like to rebuild this using GraphQL and Apollo? I've got this same user page file here that I have structured for us. And if I type in my username right now, we're not connected to the API, so we're going to get the demo Doge. But before we jump into actually connecting this query to this component, I want to show you a little bit about how I've set this project up. So I started this project using create React app with a TypeScript flag, nice and simple. And every React project I've ever worked in has had an index.js file that has actually attached our app to the DOM itself. And so what turns this from a simple React app into an Apollo React app is that we wrap our app in our Apollo provider, and we give our Apollo provider our client, which is our Apollo client. And all Apollo client needs is the URL of the GitHub API. So nice and simple, with just a few lines of code, we've turned our React app into an Apollo app, and we can now write queries. The other thing that I've done for our project is I've set this up to be an Apollo project. So I've given it an Apollo config, which is pointing to that same endpoint. So our Apollo config, based on this, knows where it can fetch a schema for us. And so because we have an Apollo config that knows where to find a schema, we have a lot of powerful Apollo tooling that can use that schema to provide type safety, which we'll look at in the demo. OK, so let's talk about how we're going to connect this query to this component. The first thing I want to point out is that the way queries are represented in GraphQL out of the box is as multi-line strings. But we all know that GraphQL is not a simple string. GraphQL is a typed language. It's very powerful. So we're going to turn on our Apollo extension, which not only gives us syntax highlighting, but because this is an Apollo project, and we've turned on our Apollo extension, we now get type definitions when we hover over these fields in our query. So we can see in our editor that on the query object, there is a field called user, which returns a nullable user type. On the user type, there's a field called login, which returns a non-nullable string. And there's a field called name, which returns a nullable string. And not only that, but if I hit Control space, I get autocomplete for the rest of the fields on my user type from my schema, from our remote endpoint. And I can see here that avatar URL is also available, which is perfect because we need that for our page. OK, now that we have all of the fields in our query, let's actually hook this up to our component. And to do that, we are going to use the useQuery hook. So if I type useQuery here, VS Code is going to automatically import it, which is very nice. We give our useQuery hook our user query name, and we give it some variables. This query needs our login variable, as you can see. And from our useQuery hook, it will return an object that we can destructure some properties from. One is data, another is loading, and another is error. So we can see here that loading is a Boolean. So if loading is true, let's return some text saying that we're loading. If we've got an error, let's return that error's message. And Apollo client will, errors in GraphQL typically come back as arrays, but Apollo client will format a nice message based on the content of those arrays for us so that it's really easy for us to access. And we'll give it a red color. But if we're not loading and we don't have any errors, we should just be able to, over here, access data.user.name, data.user.login, and data.user.avatar URL. So if I hit Command S and save, and I reload this page, the moment of truth will be if it connects to our API, which it does. So that's great. OK, the next thing that I want to show you is something called Apollo CodeGen, which has been referenced already in Bree's talk. So if I add another field to my query over here, like email, and I save my file, you might have noticed that email popped in here. And if I remove it, you might notice that email disappears. So what I've got going on in the background of my app is I've got Apollo CodeGen running in watch mode. And so I've got a process running that is looking at all of the files in our app, and it is extracting queries from those files based on the GQL tag. And then because we have our Apollo config and CodeGen is aware of our schema, it's using our schema to generate schema type-safe definitions for the responses from these queries that we have in our files. So if you remember, login is a non-nullable string, which we see here in TypeScript. But avatar is a nullable string. So over here, our TypeScript definition has string and null. So what we're going to do next is we're going to import these types and use them to get type safety on our query. And we get type safety on our query by casting the response of our hook to the types that we just imported. And the reason this is called user details is because our query's name is user details. So if I save this file again, we get a TypeScript error. And you might have noticed that we also get these red squiggly lines. And the reason we get these red squiggly lines is because we've done something that is very type unsafe. We have accessed the property user on data when data is possibly undefined. And we've also accessed the property name on user when user is possibly null. So to fix this, we'll add a simple nullability check. And we should be back in business. And I don't know about you all, but this is, to me, one of the most powerful features of the modern development workflow of Apollo and TypeScript and React. Because as a client developer, it is extremely easy to forget nullability checks, especially from queries where you're not deeply aware of the data models behind those queries. In fact, for the first few months that I was working on GraphQL, I didn't realize that I should be checking for nullability until somebody pointed it out. So I'm sure that I've shipped several bugs to production. This is absolutely the type of thing I would do. Okay, the last thing I want to show you is a project called Apollo Client Local State. And the idea with Apollo Client Local State is that we can take the schema that comes from our remote endpoints, and we can extend that with schema that is on our client side only. And this becomes a really powerful model when you, for example, want to have some local state that is persisting across sessions, and you want to be able to get that state out of queries, just like you get your data state out of queries. But my favorite use case for being able to extend the schema on the client side is that I can actually use this to mock fields in my remote endpoint that don't yet exist. So whenever we build a new feature, the first thing our team does is we decide what the schema for that feature is going to be. And by doing that, our backend team has a type-safe spec to build to, and our front-end team has a type-safe spec to scaffold from. And so the last thing we're going to do is we're going to extend this. We're going to extend our schema with a field. And we need to import GraphQL tag to do that. All right, so I think we should extend the user type. And I don't know about you all, but tomorrow's Halloween, and I'm a procrastinator, and I haven't decided what my costume is going to be yet. So I'm going to extend our user type with a costume field. So now if I go back to our user page, and we hit Control Space, we should see that costume is now available on our schema because our editor has been smart enough to identify that we extended our schema and is now providing this for us. And if we autocomplete this, we will get an @client directive, which is what tells Apollo client that this is a client-side field and not a remote field. But if I save this and our app reloads, we're going to get an error because obviously field costume doesn't exist on type user yet because we haven't defined it. So we need to write some resolvers that say what this field is going to do, specifically one resolver. And I'm thinking there's a 50-50% chance that I come to the Halloween party in my dragon costume or my unicorn costume. So we're going to write a resolver like that, and we're going to add them to Apollo client like so. We're going to command save. Now we're back in business. So let's destructure that field from our query and give it to our page. See what costume I come as. Oh, the unicorn, but I actually don't have a unicorn costume, so I'm going to come as a dragon anyways. All right, so this is a modern development workflow. TypeScript, code gen, very, very easy data fetching using the use query hook. I want to leave you all with a couple thoughts. So I'm going to switch back to my slides. Oh. Okay. First thought. We only replicated a small portion of this application, but I was actually really curious what the fully replicated version was going to be in size, because I wanted to compare. So I replicated the whole app, and not only was the fully replicated version 12 files instead of 17 files, because we didn't need to define any middleware, any actions, any reducers, we didn't need to define our store, but also it was about 250 lines of code instead of 700 lines of code. And that's including our generated TypeScript file, or our generated type def in that file, which is about 100 lines of code. So this is a 35% smaller app. So I want to leave you all with this thought. Our data layer is only going to get smarter over time. React completely transformed the alphabet soup landscape that was client development into something where we could build isolated components. And this opened the door to us being able to build component style guides and style systems with that. And Apollo, and this idea of having a data graph, they're doing the exact same thing for your data layer. They're turning a pattern that is typically very messy and very bespoke into something that is very clean, very simple, and very well understood. And what I've just shown you and how easy it can be to get set up with this workflow and get started writing queries, that's only just scratching the surface of the power that you can use with these tools. So go home and try this out. Make sure that you and your team are fully leveraging everything that this workflow has to offer you. Try out the Apollo Client 3 beta, which is what I was demoing, and let us know what you think. My name is Danielle. Come find me at the Apollo booth afterwards, or message me on Twitter if you have questions.